Hi everyone, I'm Anil Sir, your guide at Student Care Center. Get ready for engaging, informative, and fun filled educational videos that will make learning a breeze. Join me on this exciting journey as we dive into the fascinating topics together. So let's get started.
Ever wondered how you can identify whole numbers on a number line, or what the predecessor and successor of a whole number are? Let's dive into the fascinating world of whole numbers, those non-negative integers that include zero. Picture a number line, with each point representing a whole number. The predecessor is simply the number right before, while the successor is the number immediately after. Keep in mind, whole numbers, predecessors, and successors are simple, yet foundational concepts in mathematics. Adding and subtracting whole numbers might seem basic, but did you know they have special properties? Let's delve into these fascinating characteristics. First up, we have the commutative property. This means the order in which you add or subtract numbers doesn't change the result. For instance, 3 plus 2 equals 5, and 2 plus 3 equals 5 too. Next, we have the associative property. This property tells us that the way we group numbers when adding or subtracting doesn't affect the outcome. As an example, if we add 1, 2, and 3 together, it doesn't matter whether we add 1 and 2 first or 2 and 3 first, the result is the same. Finally, there's the distributive property. This one's a bit different. It's about how multiplication interacts with addition and subtraction. For example, 4 times the sum of 3 plus 2 equals 4 times 3 plus 4 times 2. Mastering these properties can make adding and subtracting whole numbers a breeze. Now that we've covered addition and subtraction, let's delve into the world of multiplication and division. These two operations, like their predecessors, have their own unique properties. Let's start with multiplication. It has the commutative property, meaning that the order of the numbers doesn't change the final result. For instance, 3 multiplied by 4 is the same as 4 multiplied by 3. It's also associative, which means that the groupings in a multiplication operation don't affect the outcome. Now, on to division. This operation is a bit different. It's not commutative or associative. However, division does have its own unique characteristic, the importance of the number 0. 0, when divided by any number, always gives 0. But remember, we can't divide a number by 0. That's undefined. Understanding these properties will certainly make multiplication and division less daunting. Ever noticed any patterns in whole numbers? They're more interesting than you might think. Whole numbers, you see, are not just random digits. They follow a certain order, a certain rhythm, a certain pattern. Every series of numbers, when added or subtracted by a constant number, creates a unique pattern. Take a series where each number is increased by 2, 1 becomes 3, 3 becomes 5, 5 becomes 7, and so on. A beautifully predictable pattern emerges. But the magic doesn't stop there. When we multiply or divide by a certain number, another distinct pattern comes to life. Multiply any number by 0, and the result is always 0. Divide any number by 1, and the result is the number itself. These are just a few examples of the fascinating patterns hidden in the world of whole numbers. Unraveling these patterns can make working with whole numbers a fascinating journey. Let's recap what we've learned about whole numbers today. We've journeyed through the world of whole numbers on a number line, predecessor, successor, and explored the properties of addition, subtraction, multiplication, and division. We've also uncovered fascinating patterns in whole numbers. Remember, mastering whole numbers is your first step towards conquering mathematics. For more help, reach out to Anil Sir at Students Care Center. Don't forget to subscribe, hit the bell icon, and leave a comment. Together, we can make learning fun.